We'll find it. Go ahead. Yeah.
Good morning, colleagues. I am Tebogo Macucwa. I'm from the Department of African Languages, and I'll be sharing about this project that me and Vukosi have been involved in, which is titled Creating Odd One Out Lexical Sets for Evaluating African Language Embeddings. So to give a background, so I met Vukosi and we've been talking about the fact that there isn't enough data for African languages in terms of creating language models. So during our discussions, we came up with a conclusion to say that how about we create a language game that we can use to compile data in order for the language models. So my research is based in the field of social linguistics. So I don't know much about NLP. So I'm just learning through these workshops and also interacting with the guys from the computer science department. So what I know is what I'll be presenting today, and then the side of building the language models and so forth. That's the information that Vukosi can tell us more about it. I just thought I should make a disclaimer. Okay, thank you. Okay. So this language game is based on lexical relations. So lexical relations is when we explore meaning of words, and specifically we've chosen to go about exploring the concept of hyponyms. So loosely, if I'm explaining what hyponyms are, when the meaning of one word is included in the meaning of another, then that relationship is described as hyponyms. As I've mentioned, that these lexical sets will be used to evaluate the semantic understanding of NLP models for African languages. And then our aim is to contribute in building better, more accurate language technologies, which explain or demonstrate our linguistic realities. The languages that we have chosen to create these lexical sets are Sepedi, Isindebele, Setswana, and Isizulu. And this is basically the scope and objective of the task, how we went about creating these data sets. So we have 100 lexical sets, meaning that we have 100 superordinate terms. And then a superordinate term basically is the word that describes a category, a certain category. So as I've demonstrated there in the brackets, that, for example, we can take the word vegetable as a superordinate term. Then following that, we came up with cohyponyms or hyponyms of the superordinate term. So the cohyponyms are words that fall under the category that is mentioned. So examples would be words like carrot, cabbage, broccoli, and so forth. So meaning that already we have 4 words, and then the other 2 categories are one related but odd word, and then followed by a completely unrelated word. So according to my understanding is that the model needs to understand which words are related to the superordinate and which word is completely odd, or which one is related but odd. So for related word but which is odd, I gave an example of an apple, because both an apple and carrot are, we can say, they fall under food. And then for one completely unrelated word, I gave an example of a man, because a man, it's completely unrelated to the superordinate term vegetable. And then this is an example of how we presented our data. So here we have two superordinate terms. I've spoken about vegetable already, and then we have another one which is dog. And then we have three related words, which are our three core hyponyms, and then followed by the related but odd word. And then lastly, the odd word, which does not have any meaning, which is included in the superordinate terms. So currently we have about, I think, 2,400 words, which include the 4 languages that I've spoke about. And then it's basically the data that we will be developing and building the language models according to the idea that I've just presented. Yeah, that is all from me. Thanks a lot.
Thanks. Yeah, I guess I'll add the last context in the last 30 seconds. So one of the things that's a challenge is, okay, hey, you want to build the language models, let's say, as an example. The large language models, you need a lot of compute, you need a lot of data. One of the things we can enable, though, is how do we expand the amount of available evaluation sets? This is, again, where it's important to bring in language specialists and linguists, because in the same way that we look at maybe how we assess the learning of concepts for children or for humans when they're learning a language, why can't we transfer some of that knowledge into then doing and actually evaluating large language models in that way? So this is one of those projects that is in that space that we will you will hear from Abebe, one of our postdocs, in terms of his work. And that's also connected to here of saying now, in the new ways that you can improve representations for words, for language models, can then we evaluate and see if our improvements on the mathematical side are giving us gains on more the grounded linguistic actually properties that are being learned inside the large language models themselves. So that was that. So thanks. And then let me go. Sorry. And obviously you chose the wrong one. Okay, maybe Abebe. You wanna come up? Yeah.
Okay, good morning, everyone. I am Abebe Tegene from AI4D Postdoctoral Fellow under the supervision of Prof. Vukosi, Marivate, and Prof. Banda. So our research focuses on innovation in word embedding models to capture the unique linguistic richness of African language. So our presentation includes try to see the overview of African language. Then we try to see the challenge, and we'll see the methodology or the approach that we follow to improve this linguistic richness of African language. Thank you. So when we come to the overview of African and linguistic diversity, the continent have one of the largest continent with diverse language, which accounts about 31% of world's language, and it is a home for more than 2,000 language with diverse dialects and structures. But still, this language is considered as low resource language, and whereas this diversity become an opportunity as well as become also a challenge. So it is a large potential for NLP innovations. So what are the challenges in African language NLP? So there are two major categories. We'll have the data challenge and we'll have the linguistic challenge. When you come to the data challenge, we have data scarcity. We have limited corpora for most African language. We have seen as 92% lack this digitized text and 97% have no annotated data set. So the other limitation is on model. So existing model are not optimized for low resource settings because most of them are developed for high resource Indo-European language. So when it comes to the linguistic challenge, the language by itself has complex linguistic structure. It is rich, it has rich morphology, and it has a different tonal system, and it has varied scripts. So this makes poor NLP performance for African language, and existing models focus on high resource language. So model like word2vec, Globe, or fast text struggles to capture these unique African language structures. So we focus on embeddings. Why word embedding? Because embeddings are the fundamental structure for natural language processing. So because the embeddings capture the meaning and the context of a word, and they improve the language understanding, and they support this low resource setting, they enable better NLP applications. So how can we tackle this challenge? So we have developed a mathematical and computational model for better word embedding in low resource African language. So we actually do our project with collaboration with computer science and mathematics and applied mathematics department. And so far we try to develop extend the existing Globe model, and we try to test it for a CPD language, and we succeed. We have a better performance. So our next approach is to study the mathematical structure of the embedding and to integrate the linguistic structure and to build context-aware representation. So our contribution will be to develop new embedding framework for African language, and to develop a linguistically informed AI model, and to open sources for language. So we are going to release our embeddings and our algorithms. So word embedding for African language have important impacts and technological impacts for the society. One of the technological impacts is on the technological advancement. It can improve the natural language processing applications systems like translation, speech recognition, and search chatbots and search engines. So they also improve the digital inclusion by expanding access to technology, education, and information in the native language. They also act as a research foundation or stepping stone for building African-centered pre-trained language models and large language models. So in summary, we have African languages still remain underrepresented in NLP research. So existing word embedding model have limitation in low resource setting because most of them are developed for high resource Indo-European language. So our research focuses on improving this word representation for African language. So at last, we are saying that advancing word embedding for African languages is essential to bring millions of underrepresented speakers into the digital world by building inclusive, accurate, and social impactful NLPs. Thank you.
Thank you. All right, and then, sorry, said these are rapid. Fiskani, sorry. And then who's this? Penelope, just prepare yourself as well. Do you want to hold it or you want? Yeah? Oh, just press. Should work. Sorry. Okay. It's just, yeah. Sometimes I'm an idiot. So.
Okay, morning. My name is Fiskani Banda. I'm a PhD student who's being supervised by Prof. Marivate and Dr. Joyce.
Just make sure. Yeah.
Okay. And my project is titled Towards Language Aware RAG. Okay, so given a simple scenario, recently we have been experiencing a lot of rain, which can cause fields to erode and also cause the soil to dry out. And in such an instance, when you're growing crop, your crop can be stunted. So given such a scenario, one can use an AI tool to basically ask the question, what can I do to basically ensure that my crop grows, or how do I basically prevent the soil from eroding? Given that scenario, we are given 3 options. The first one is using precision no-till machinery. The second one is using a method known as Lekoti. And the third one is using a zero-budget natural farming method, which uses fermented microbial cultures. So technically, all of these answers are correct. But for the first one, the no-till precision in a country like ours, this would be very expensive for someone to try to use. The third one, the low budget one, it is low budget, but this method has only been tested in India, so therefore we don't know whether it will work for us. And the second one, the Lekoti method, has been tried and tested in Lesotho, so therefore that's something that we can test. But these are options that can be given to you, and it's very hard to decipher which ones are useful to us and which ones are not useful to us. So this highlights the importance of context-aware systems. So the problem we're faced with is that conventional large language models have 2 things going on: hallucinations, where they provide you with factually incorrect answers, and then you also have a knowledge void, where they don't really have a lot of information about farming in South Africa. So one solution is to look at retrieval augmented generation, which basically, instead of just using a large language model, you add a database which has curated information about farming, and then you also add a retriever. So the retriever is there to basically get the question that someone is asking, use that question to then retrieve the most relevant documents, and then provide that information to the model, and then the model then gives you the final answer. So the current state of the research right now is that for low resource languages and for low resource languages, the current approach for most of the systems is basically a trial and error design. So you basically work through different models, you try all of them out and try to figure out which configuration works best for your scenario, which can be expensive and take a lot of time. So what we are trying to do here is to see whether or not we can use the characteristics of our language and data to make more informed decisions before we even start building the system. Okay. So the research is basically in 3 stages right now. We have data, which is provided by Grain SA about farming, and that data is in 5 languages. And then we basically use that data to then get question answer pairs. And then for that, afterwards, we basically perform comparative error analysis. So we look at previous implementations and try to figure out what trends are there that already exist, and then from those basically try to identify where and how these mechanisms fail, and then design an experiment based on this. And the last part is basically validation and best practices. So at the end of the day, we want to try to correlate the behavior of the model with what the data is and the language. Okay, so it's just some results, I guess. We have done a bit of experimentation just using the most commonly used retrieval mechanisms. And from that, we have made 2 observations. The first one is that when you're trying to get the relevant document, the retriever assigns a score to it, and then you use that score to basically determine how relevant the document is. So in our case, for most of these, the scores are very close together that it's very hard to basically discriminate whether or not the provided document is actually relevant, or it's just relevant in terms of the theme. So it kind of addresses the issue, but it's not really informative for the system. And the next one is named entities. So for most of the mechanisms, they tend to pick keywords. So let's say you have like a keyword like AgriCloud, which is an app that is out there for farmers. It will basically give you documents with that keyword, but that document does not necessarily mean that it's basically relevant to the question that has been asked. So with this, then we have one gap, which is basically you are getting relevant information, but that information is not informative for what we are trying to do. Okay. So basically the scientific contribution here that we're basically trying to establish some best practices that when you start off with a system, you kind of know the things that you should be considering when given a language and given the data that you have. And then the other thing is basically we have a interface, which basically we're trying to basically just build a system where farmers can basically ask questions and then use the information that we have to basically get data. And the point of this is to try to also get feedback from the community about what we are trying to basically push towards. And yeah, and I guess, yeah, so call for action. If you want to see kind of the conceptual idea of the interface, you can come and I can show you a demo. But thank you.
Okay, I'm going to steal another 30 seconds for this one. Oh, no, thanks, Fiskani. With this one, yeah, connection again. Given the first panel, the Grain SA data is through Sarila, right? And it's a way of us of actually figuring out ways that, yes, we might not have fully all the frameworks, but then we want to do the work, right? So in this case, Sarila work through the UP node. There's a node here, and then also main Sarila to say, how do we make this available, and then how do we see what actually can be done? And for Fiskani, she's building on top of her master's work and continuing now into this other space in more for the PhD. Okay, and quickly the final one.
Right, thank you.
Yeah.
Good day, everyone. My name is Penelope Matloga, and I'm a PhD student supervised by Prof. Vukosi and Idris. So let's start by just imagining we are trying to build a system, right, that understands a certain language like Sepedi, and then it has a little data in it. So it also has languages that it mixes with other languages when people talk in one sentence, and then constantly changing depending on the context. Well, this is the reality that we are facing in South Africa because of the multilingual communities that we have. Sorry, I nearly went ahead without showing you my slides. Okay. So my work focuses on improving how models understand languages that are underrepresented, particularly in South Africa. So the problem, NLP needs large label data, and currently is heavily, there's a lot of unlabeled data that are available on social media and everywhere, even on platforms for work, in most systems. So, but then in low resource settings, especially in South Africa, this data is very scarce. So on top of that, people often code switch when they are talking, and then even when they are writing, and then meaning they switch between languages within the same sentence. This create additional challenges like the ambiguity, informal speeches, and also linguistic complex. Therefore, this leads to the poor model performance. And then there are multiple challenges that are involved in this, like the lack of annotated data, then the label noise in automated methods, and also linguistic complexity, like code switching and ambiguity. So the proposed solution is that we are proposing. So the question becomes, how do we build accurate language models when we don't have enough quality data? So this is where I come in. My research explores a solution called pseudo-labeling. So pseudo-labeling allows us to use unlabeled data by letting models generate their own labels. So this helps us to expand data without mostly manual annotation. So we are gonna use large language models that are already there. We just have to improve them with the data that we have. So, however, there's a lot of majority problems. These automatically generated labels can be very noisy, and then meaning they are sometimes incorrect, and then there's also error accumulate. Then that affects the model, and the model drops the performance. Then so improving this model is very essential. So the approach that we begin with is just we begin with a systematic literature review to understand what has already been done, and then the findings show that while pseudo labeling is widely used, it often struggles with noise and reliability, especially in multilingual and low resource contexts like South Africa. So based on this, I propose a noise-aware pseudo-labeling framework. This framework combines the following stages. So the first one is the using large language models to generate initial pseudo-labels that are, and then secondly, unreliable labels are filtered, and then using confidence and agreement techniques. And then the iterative self-training allows the model to gradually improve by learning from cleaner data over time. So the impact, the proposed framework aim to reduce the noise and improve classification accuracy, even when working with limited and complex data, and also create more reliable NLP systems, especially in code switch and low resource settings. So the broader impact is also significant. Ultimately, this research will contribute to bridging the digital language divide, ensuring that South African languages are not left behind in the development of intelligent systems. So why is it matter? So this matters because language technologies power tools used in different sectors such as education, healthcare, private and public services, and improving NLP for low resource languages, code switch languages has real world impact. It can enhance technologies used. Sorry. Okay. I forgot about the slides actually. Apologies. So it can enhance technology used in these sectors, making them more inclusive and accessible to diverse communities. So because if local languages are not supported, many communities risk being excluded from these technologies, as the speakers have already mentioned in the previous collaboration. So in conclusion, reliable pseudo-labeling can unlock the power of unlabeled data and enable better language technologies for underrepresented communities. Thank you.
Thanks. Okay. I think we have a tea break now. I don't know if there's instructions or no instructions. Okay. Okay. My instructions. We have a tea break at the moment, so you can go out. We'll be back at 11:30. Please engage with somebody you don't know. All right. That's the thing here. That's why we brought in the people that we brought in this space. Tebogo will be leaving soon because he has teaching. So he might have a few minutes. If you need to talk to him, I'm just giving that warning in that space, because you should give him a lot of questions. And we're hoping that project in terms of data being available by the end of the year. So for now, we're going to on break, and everybody online will just switch off the camera and mute, and we'll be back in 22 minutes.